We have here several laws. Generally, there's 7 in course books, including the fractional or negative index. An index is a small number that tells us how many times a term has been multiplied by itself, we say. The plural is indices and a singular is index. We're going to look at some exam questions today. It'll be 5 or 6. So we're starting from a certain point. So we're looking at a power or exponent that's raised to a number, and in a few cases to a variable as well. In algebra, we come across these quite often in GCSE and beyond. And we'll also be dealing how maybe the constant or a base, as you might call it, can be changed as well. Even on the first question, actually. Let's have a look. 25 is equal to 125 raised to k. Find the value of k. So what we do here is we have to think to ourselves, we have to get something more consistent than what we have. And it's just a little trick of what these are, that you can change the constant or variable to suit yourself in some cases. With this particular set of numbers, we can write 25 as 5 squared and 125 as 5 cubed times k. And really just from there, we have the same base, 5 and 5, so we can make 2 equal to 3k. And our answer is k is equal to 2 over 3. Okay, let's keep going. Here's a very common question. We'll have negative or fractional index. If you see a minus sign, I mean, the quickest way to do it is just to flip it, so to speak. So let's just do that. Power of 3. So 4 over 3 is our index. I've just demonstrated that it'll be seen here in your law. So generally your first and second laws are when you multiply and divide, you'd add and subtract the exponent. The third one is often anything inside brackets, you'd multiply it out. And there are a few more, as you can see in the bottom 3 here, dealing with the negative or fractional index or indices. So from there, we rewrite this as possibly the best way to do. Just rewrite it with your powers and roots. The power on top, the root on the bottom. So let's just put it here. Root, so cube, root, a to the power of 4. And the same with the denominator, x to the power of 3. Put little brackets. Let's make it more easier to look at. And from there, I mean, students have different ways of doing this. What's the easiest route for you? Maybe find the root, the cube root of 8, which is 2, and then 2 to the power of 4 is 16. You kind of find your own way of doing these sometimes a little bit. So investigate it yourself. And the same with the basis, x to the power of 4. That's our answer there. Next one, similar, pretty much the same. Just these come up very often, so you should practice a few of them with different variations on the constant, variables, and so on. So we'll do the same thing again. We'll flip it. One third. This one's a bit easier actually. So we end up with a cube root for m3, m to the power of 3, and a cube root for 64. And our answer down here is m over 4. That's your final answer. So they're very common, those 3 types. come to a few more questions now, maybe where we have a unknown variable in the index. So 2p, 2 to the power of p I should say, is equal to 1 all over 8 to the power of 4, and find p. So 2 to the p. I'm going to rewrite 1 over 8 to the power of 4 in a negative index. And next, what I want to do is get the same base. I know that 2 times 2 times 2 is 8. And we're at minus 4 there. So essentially, this is very similar to the first question we had, where we had our 5s. And we just basically take out the exponent. So p is equal to 3 times minus 4. As you can see here, so it's minus 12. That's our answer there. Maybe just 2 more little challenging ones, but this one's very similar to a previous one we just did. I'm going to set it up fairly quickly. So y 20 over 16 w to the power of 8, sorry. We've got minus, so we've flipped it already. I've got 3 over 4, so that's root 4. And our 3 goes on the outside, so that put your bracket in just to make it very clear what you're doing. And from there you get y times, so it's y 60. And I'm going to leave that actually. Might be quicker just to show it like that way. So y 60 and then, yeah, y 15. I'll just do it like that. Y to the power of 15 over 8 w6. The same skills of what you've previously just done there, so you will know from your power root calculations from this part, question C, we'll say. Just basically do the same there for this challenging one here. Last question. 4 to the k plus 3 is equal to 16 times 2 to the k. 2 to the k. So we want to get them on the same base. So 2 squared is 4. And then times k plus 3 is equal to 2 to the power of 4 times 2 to the power of k. And now we have the same again from previous questions. So I'm going to multiply this out in one go. 2k plus 6 is equal to 4 plus k. Be careful there, it's a plus. When you multiply exponents, you're adding them out, the variables. 2k plus 6, so we'll just basically do your basic algebra there. 2k is minus 2. K is equal to minus 2. And there are a few examples of questions that come up very often in those kind of forms on GCSE papers. So the laws of indices, powers and roots.